Coming up in our global quest for the greatest engineering disasters, a Baltimore sewer that's laying waste to a town.
The city is releasing tens of millions of gallons of raw sewage into the harbor.
A housing estate in Ireland with a distinct sinking feeling.
The ground has settled well beyond what the houses have settled.
An eccentric Italian count's vision for a millionaire's playground.
What Count Bagno used to call the city of toys turned into a city of disaster.
And a crossing catastrophe that nearly ran off the rails.
The potential of so many people being injured or killed, it was just a shock.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings. These are the massive engineering mistakes that only an expert can hope to fix. When engineering goes wrong, the fail can happen suddenly and in plain view. But sometimes calamities unravel slowly, and nobody is any the wiser until it's too late. Like this first construction catastrophe in Maryland, an engineering problem that really stinks.
This engineering blunder is enough to turn your stomach.
There's a 10-mile sewage backup underneath the city of Baltimore.
This aging sewage system was laying waste to parts of the city.
The stream flowed over. The sewage came with it.
Ever since Baltimore was established in 1729, this port town has lived and breathed water.
Baltimore is an old East Coast city, dating back to the 1700s. And like most old cities, it is fraught with aging infrastructure.
This old town has a very old sewage system. By the 1980s, the city's antiquated sewer system was among the most contaminated in America.
The early sewer pipes and storm drains were made out of clay, concrete, brick, and even wood. And as a result of this, over time, they've cracked, allowing sewage, raw sewage, into the waterways.
But it wasn't just age causing trouble with the city's waterworks. A fundamental part of the problem was the way the pipes were laid in the first place, something environmental biologist Alice Volpitta knows all too well.
Our pipe infrastructure is laid in such a way that the sewer lines, the sanitary sewer lines, are placed directly next to the stormwater lines. And both of these systems are very old and crumbling. So over time, what can happen is raw sewage can just leak out of those cracks in the sanitary sewer system and go directly into the neighboring pipe, which is the stormwater system. And once that happens, because the stormwater system isn't designed to be treated by a wastewater treatment plant, you just get raw sewage flowing through the system into the next waterway.
The storm drains that carry rain and groundwater are constructed lower than the sewage pipes which take the waste to be treated. This means that when cracks appear in the aged infrastructure, untreated sewage can leak into the storm pipe below, flowing straight into the river, which in this case is the Jones Falls.
We're here at the Jones Falls along Falls Road in Baltimore City, Maryland, and today we're going to be taking some samples of effluent from a stormwater pipe to see if we can find any evidence of sewage contamination. This is supposed to be part of the stormwater system, so that means that after about 48 hours of dry time, there shouldn't be any liquid running out of these outfalls. But this spot is chronically contaminated, so in the past we found sewage contamination coming out of these outfalls. We can do an ammonia test to see if there's any ammonia present in the water. And if there's more than 0.3 milligrams per liter of ammonia in our water, that's a really good indication that what we're seeing is sewage. Okay, So we have a reading of 0.58 milligrams per liter of ammonia here, and anything greater than 0.3 milligrams per liter is a pretty good indication of sewage in the water. The ammonia test is indicating that we have sewage in the stormwater right now. So now that we've identified a potential sewage leak, we're going to report this to Baltimore City so that they can conduct their own follow-up investigation, find the problem, and fix it.
Baltimore's stormwater flows into a stream called Jones Falls, and it's unsurprising that effluent from the cracked sewer pipes found its way there.
It's a problem that long-suffering residents like Helena Hicks have encountered far too often.
The Jones Falls is really our sewage system. So the fact that we get raw sewage, I guess, shouldn't be a surprise because that has been the sewage line for Baltimore forever.
The contamination isn't just a local problem. The Jones Falls River runs directly through Baltimore, so much of the city is affected. Environmental journalist Tom Pelton has been monitoring pollution levels in the downtown Inner Harbor area for years.
It looks beautiful, but when we did sampling of the bacteria levels in the harbor, we found that 35% of the time, fecal bacteria levels are too high for human contact.
The level of effluent in this city's harbor has been 400 times above safe levels.
So that's a serious public health problem when we have kids playing down here in canoes and kayaks and the dragon boats that are very popular. It's not safe. And we had some public health experts look at the data and say that there should be warning signs for the public not to have contact with the water. If we could only clean up the sewage problem, it would be a place where we could fish and swim and enjoy without having to wear rubber gloves to avoid the bacteria levels.
In 2002, Baltimore was told to clean up its act and sued by the Environmental Protection Agency every time raw sewage was discharged into the river. The city had until 2016 to fix things once and for all, or face massive fines.
It's a problem that the U.S. Justice Department sued the city over, and now the city is compelled to fix its leaky sewer system.
One of the city's solutions is to close and repair sewage outflow pipes to prevent cross-contamination. The fix will include 460 kilometers of so-called cured-in-place pipes inside the 23 original sewer lines. Cured-in-place pipes are created by inflating balloon-like linings made of resin, fiberglass, and felt within cracked pipes. As the pipe is inflated, the material hardens or cures and seals the old walls from the inside, eliminating the need to replace them. Engineers also regularly examine the lines with a remote camera for any new cracks or root growth that has damaged the pipes. Jeremy Richards is helping the city to flush out the problem.
Today it's an investigation. The city is looking to see the condition of the pipe, on what their next step for maintenance would be, whether there's an issue where it would need to be replaced, it could be lined, or nothing at all. This is a clay pipe that's probably 70, 80 years old. It's broken in this location.
Any damage to the clay pipes has to be fixed to prevent soil and roots from clogging them and to stop sewage getting out.
At some point, if it isn't repaired, this will fall out of the pipe. This will be missing. And what you will see is more than likely soil or the gap that it has left.
This is a long and ongoing project. By 2016, not only had Baltimore failed to fix its pipes, but that February, one of the heaviest storms ever to hit the city made this sewage nightmare a whole lot worse.
What was happening was the sewer and the storm drains were so full that this household toilet waste had just nowhere to go. And so it ended up backing up into people's basements.
Nearly 10 million gallons of untreated water was released into Baltimore's waterways, carrying with it bacteria and viruses that could cause diseases.
Gradually, the more homes they built, the more the underground water system started finding its way into the neighborhoods.
Officials realized that their problems were compounded by building part of the city on a floodplain. Floodplains are areas of flat land beside a river or stream. The level ground makes them appealing for construction. But as the name suggests, they are also at much greater risk from flooding.
When we had the big flood, which put us on the map, where most of the homes flooded, then they began to realize what they had done, that they had built a neighborhood really on top of an active stream bed.
It doesn't take much imagination. If you put a building on top of a watercourse, be it a river or a stream, you're gonna get some flooding.
Once again, Baltimore had to act and took a huge step towards cleaning up the city's sewage problem. They're building a $430 million water treatment plant, the Headworks project, scheduled for completion by 2020. Monty Simon is project managing this ambitious construction.
We're currently standing in our core stream facility. In about 24 months, you'll have this online and we'll be treating about 800 million gallons a day of sewage. At the end of the day, this project is very large. It's going to solve about 80% of the sanitary sewer overflows that are in this collection system. Directly for the citizens, you're going to have a lot of the backups into the houses and whatnot will be taken care of. And also your surrounding waters like the Inner Harbor and the ultimate Chesapeake Bay will be cleaned up by this project. So I think it'll be a great benefit to all of the citizens of Baltimore.
It might have taken decades and will ultimately cost billions, but it looks like Baltimore is finally solving its sewage problems, although some residents remain skeptical.
We're not sure whether or not the Headworks project is going to fix all of our problems. I certainly do hope that it reduces sewage overflows, because sewage is the #1 pollutant to our streams and our harbor, and it's causing the waterways to be unsafe to recreate in, to fish in, to boat in, swim in, and it's also really causing a lot of ecological damage to our waterways.
The good news is, though, this problem is finally receiving the attention and investment it deserves.
There's so much potential down here at the harbor. It's such a gorgeous place, and if we could only clean up the water, it'll be so much more attractive to the businesses and the restaurants and all the condos and homes.
Some engineering disasters develop over time and become harder and harder to live with. But when a construction calamity suddenly comes to a head, the outcome can be life or death. For this story, we head to Ireland and an engineering catastrophe that came to the end of the line.
Hundreds of people's lives were at risk.
Only luck prevented this construction calamity from becoming a major disaster.
Potential of so many people being injured or killed, it was just a shock.
If this train were 10 minutes late, it would have ended in tragedy.
Malahide in Ireland lies just 16 kilometers north of Dublin. This sleepy coastal town enjoys all the benefits of seaside life. It's also home to the Broadmeadow Viaduct that carries more than 10,000 commuters a day over the Broadmeadow estuary to Dublin. But on August 21st, 2009, this small community was nearly derailed by catastrophe. Rail spokesman Barry Kenny remembers the events of the day.
It was a Friday evening. People were commuting home from work. It was a lovely sunny evening. And our line here is a very busy line. There'll be 17,000 people every day who cross it. So a train crossed going north And then the southbound train came along about 95 seconds later. And as it was crossing, the driver of the train, Keith Farrelly, noticed splashing coming up beside his train.
Water splashing from the sea onto a 200-ton train might not sound like a big deal, but the driver immediately knew that something was very wrong. The bridge appeared to be collapsing beneath the train, as rail spokesman Barry Kenny recalls.
The driver of the train, Keith Farrelly, looked to his side. He could actually see that the pier on the viaduct was giving way, realised the danger that he, the train and the customers on board were in, and reacted perfectly in terms of putting the train into coast. And he immediately contacted our signaller. So within 7 seconds, the signaller had been alerted, and another 15 seconds later had set all signals to red to make sure that no other trains could enter the section. Keith, when he got to Malahide station, then walked back and saw what has happened, and as he said at the time, his legs turned to jelly.
The driver's quick thinking had not only averted disaster, but by bringing the entire line to a halt, he'd prevented a potential tragedy. Train engineer Eamon Balance realized how close the town had come to catastrophe.
It was a Friday evening. I was at home and I got a call who advised me there was some problem in Malahide. I arrived in Malahide station and walked out towards the site of the bridge. What greeted me there was quite startling. Pier 4 had been washed away, and the two spans resting on Pier 4 were lying in the water with a torrent of water flowing on, through and above them.
Quite clearly, we had narrowly averted what could have been simply an enormous tragedy, but we're also then facing extended disruption to a line that thousands rely on every day for their commuting.
Although this disaster happened one summer evening, the seeds of the engineering failure were sown more than 150 years earlier.
The railway was built in around the early 1840s. The original viaduct was made of timber, and it was supported into the seabed using timber piles.
Because of the strong tidal flow in and out of the estuary, the timber piles supporting the first bridge were susceptible to erosion. To reduce the volume of water washing in and out, a stone weir was constructed along the entire length of the structure.
Basically, they built an embankment which is substantially underwater to protect the piles from erosion.
This embankment, or weir, was made of large stones placed underwater around the timber supports.
A weir can be used to control the direction and pace of a river, protecting structures like the bridge from erosion.
To replenish material washed away by the sea, engineers would drop stones from the train through the gaps between the rails as they passed over the viaduct.
In 1860 approximately, they built a new bridge. And the bridge was built of wrought iron construction, resting on masonry piers.
In the 1960s, the bridge was replaced again with a modern concrete structure which wasn't susceptible to erosion. But engineers had overlooked one crucial thing.
The installation of the new concrete beams meant you had a solid floor on the bridge, and it was now impossible to replenish the weir by trains dropping stone. The solution arrived at was to grout up the weir. This basically involved injecting liquid cement into the stone structure. So effectively they grouted up the entire crest of the weir under the piers all the way across. This was thought then to remove the need for future maintenance. It basically locked the stones in place.
Grout is a dense liquid like glue that binds the rocks together underneath the water. However, it's permeable, so water can flow through.
Back then, engineers thought the grouting solution was a permanent fix to an age-old problem. So over time, the aging weir supporting the bridge was forgotten, as accident investigator Jill Lowry discovered.
Historically, information about the viaduct was passed by word of mouth. However, engineers that knew about this had moved to a different division. So the engineers in place at the time of the collapse of the viaduct incorrectly assumed that the masonry piers were supported by the bedrock of the estuary, where in fact they were supported by a permeable weir.
People forgot acknowledged to a great extent that the weir existed. There was no concept really of the extent of the weir and the need to maintain it.
With old structures like this, the original plans can sometimes be lost in history, lost in the ether. No one knew what was underneath.
In 1997, an inspection was carried out, and engineers discovered that the weir under Pier 4 was eroding. But it seems the report was misfiled rather than acted upon.
There was a hidden problem. The grout was being washed away slowly, and the weir was becoming again a non-confined structure. It was becoming unstable.
Just 7 days before the catastrophic collapse, an unintentional inspection was carried out by local resident Ivan Barrett. While Ivan was kayaking on the estuary, he spotted something alarming.
We went out paddling on a Friday night, and we discovered that a rock had been washed away at the base of the fourth pillar, and the flow, instead of going right through the centre of the waterway away from the pillars, was now being diverted against the pillar. So after the weekend on the Monday morning, I made a call to Irish Rail, explained it through, and I suppose even at that stage myself, I thought there was a danger, but not imminent, that I thought maybe months out something may happen. But as far as I remember, the course of the conversation said, well, look, if something isn't done about this at some stage, there is the potential it's going to fall down. I subsequently discovered Irish Rail did have a look at the bridge and the structure on the Wednesday.
From the photographs that the engineer took, we can see that there was serious undermining of Pier 4 occurring. Tunnel-like erosion started occurring. A whirlpool had formed around the base of Pier 4.
Years of erosion had weakened the piers, and without sufficient maintenance, the outcome was inevitable.
2 days later, the fourth pier gave way, taking a piece of bridge with it and almost a train full of people.
Thanks to the quick thinking of the driver, disaster was averted. But Irish Rail was under pressure to come up with a more permanent solution.
For Pier 4, which was washed away and in fact never seen again, we never even found the pieces of Pier 4 because of the fast-flowing water, it was determined that a totally new pier would be piled into the seabed.
Pier 4 was completely rebuilt, and the remaining piers were reinforced by driving steel piles deep into the seabed.
It was determined that the weir could be reinstated safely to a new design with heavier materials and a new shape profile.
Thanks to new solid foundations, this bridge won't be going off the rails anytime soon.
The tracks were just dangling in mid-air. If a train had gone over them, it would have ended up in the estuary.
The legacy that remains with locals and commuters is that a great tragedy was narrowly averted.
I think there was a sense of what didn't happen. At the back of their minds was like, but you know what? It happened and nobody was hurt and nobody was killed.
I remember how shocked everybody was when they realised the only reason people noticed this was because a driver saw it at the corner of his eye, and if he didn't, dozens of people would have been hurt.
Although this event was shocking, one good thing did come out of the reconstructed viaduct.
A major positive development out of the incident was that Irish Rail then met with both the Malahide Scouts leadership and members of the Irish Canoe Union to see could they include something within the redeveloped foundations that would help our canoeing program. So beside the fourth pillar area, they put in basically a sluice gate. It was 28 metres long, and it provides a route for canoes to go down, and it throws a whitewater wave up on the bottom, which makes for very good whitewater canoeing, and it's a really excellent training area.
It's great that some good has come from this, but let's hope that lessons have been learnt.
You've got to take your hats off to that train driver. His cool, calm actions under such pressure may have saved not only his life, but the entire train full of people.
Most engineering projects are built with society's best interests at heart. But sometimes, construction enterprises are born as flights of fancy and end in disaster. Like this story in Italy, with an engineering project that was the downfall of a whole town.
Count Bagno completely flattened off the ancient village of Consonno.
A count with a grand plan and an appetite for destruction.
Conte Mario Bagno la fece abbassare con gli esplosivi.
This is every architect's dream turned into a nightmare.
An ambitious construction that was sliding out of control.
One man's vision just kept slipping away.
If you fight nature, nature will fight back.
Consonno nestles in the foothills of the Alps in northern Italy. Villagers lived here peacefully for hundreds of years. But all of that changed in the second half of the 20th century, as former Mayor Antonio Giraldi recalls.
Fino al primo dopoguerra, 1950-52, tutti lavoravano la campagna e così. Poi ha incominciato a svilupparsi un po' l'industria a valle e quindi qualche persona ha incominciato ad andare a lavorare nell'industria e così via.
With villagers taking jobs in nearby towns, an eccentric Count Mario Bagno saw an opportunity to buy up land in Consonno and build his dream.
This guy wanted to build his own version of Las Vegas in Italy.
The Count's vision included a casino, nightclub, shops and restaurants, a millionaire's playground. Environmental engineer Franco Cavalieri remembers the inspiration behind this bizarre project.
In the early 1960s, Italy, and especially this part of Italy, north of Milan, was experiencing never known before wealth. And they wanted to live like the Americans. They were watching on TV movies from Hollywood, and they were admiring the American way of life. And Mario Bagno wanted to leverage on this, and he started to build this place following Las Vegas or Disneyland.
The Count had the perfect plan, the perfect location. Even an ancient hilltop village wasn't going to stand in his way.
Mario Bagno wanted to make money as quick as possible, so he bought this place cheap. He completely flattened off the village, the ancient village of Consonno.
It simply beggars belief to blow up a village that's been there for centuries. It seems like madness.
While obliterating a 1,000-year-old village was no problem for the Count, historian Katia Brilli believes it was devastating for residents.
Many old people who had been living their entire life here in the village were very resented of the idea of moving away, of leaving their old idyllic town and change totally their own life. So this represented a great trauma for many people, especially the older.
With the village destroyed and the people displaced, Count Bagno could begin his elaborate construction. With the relaxed building regulations of the 1960s, as architect Anko Racek makes clear, the Count had a free hand to realize his vision.
People didn't really take into account the environment, they didn't take into account any context, and as we can see, it was possible for someone to come purchase a whole place and flatten it completely just to build his dream.
What's more, as Giovanni Zardoni expands, the unconventional Count had his own inimitable style.
La particolarità di Consonno è che Bagno aveva messo un sacco di stili, dallo stile arabo a una pagoda cinese che stava tra due fontane con queste sculture per l'epoca moderne che avevano all'interno una palla da discoteca, quella con gli specchietti, che veniva fatta ruotare dall'acqua che cadeva, illuminava tutta la zona. Alle spalle della fontana vi era il grande Hotel Plaza e all'interrato il Night.
Very kitsch, very tasteless, completely different from the traditional Italian taste for life.
They called it the city of toys. So it was this playground for the rich, for the elite of Milan, where they were going to go and spend their evenings, spend their money in a beautiful location.
the City of Toys opened while construction was still underway, to huge excitement.
It was the 60s. It was new and exciting. If you had money to blow, this was the place to be. And people loved it.
The rich and famous came from all over Italy to revel in the Count's exclusive creation.
This was a real big kids' playground. A casino, restaurant, nightclub, a multitude of shops.
Now, all the spaces here were shops for tourists. Here they were selling all kinds of usual, regular gadgets and items and gifts for tourists. Nothing particularly interesting, nothing particularly tasteful, really kitsch. But it was the core of the places, the shops, where people spend their money.
Era occupata da un ristorante panoramico, queste erano tutte le finestre del ristorante panoramico, e poi iniziava la galleria dei negozi.
But the fun was short-lived. Soon after opening, the resort began to lose its footing, quite literally.
It was not long after the Consonno opened to the public that what Count Bagno used to call the City of Toys turned into a city of disaster. The road originated to Consonno was hit by landslides. There were 6 of them, and they all took place in different times. Over the 10 years the park was open.
A landslide is usually a rather sudden event and can have devastating consequences. In this instance, car parks and roads were completely destroyed.
Constant landslides meant constant repairs, and in some cases, complete rebuilds. It was as if the Count's dream of an Italian Las Vegas was never meant to be.
The ancient village of Consonno had stood firm for 1,000 years. But once the Count built his City of Toys, the village was hit by 3 landslides in just 10 years. As any engineer knows, the original vegetation on the hillside would have been vital to the town's stability.
The village was surrounded by dense forests. Now, this didn't suit the Count. But what he didn't know is the root structure was integral for the stability of the land.
The roots of the trees and shrubs were spread throughout the soil, holding the ground in place on the hillside. Digging them out to make space for buildings removed this natural protection against landslides.
There was a massive deforestation of the area, so many trees were lost, even roots were eradicated, and that left a large part of the area without the support of the roots that in the previous time kept the soil together.
The material the Count used for construction added to the problem.
He wanted to be quick, so he made use of a lot of concrete, a cheap material for building construction that was easily available, would cost little money, and would allow for a very quick building time. So with so much buildings, heavy buildings on the top of the hill began slowly going down.
When you've got unstable ground, the worst thing to do is to build massive, heavy concrete structures. It's a wonder that some of these things are still standing.
Not only were concrete buildings too heavy, the machinery used to build them was part of their downfall.
Also, the building with the support of so many bulldozers and so many heavy trucks had a negative impact on the resistance, on the resilience of the soil, which was very soft.
As if that wasn't enough, the Count resorted to explosives to ensure the very best views for his guests.
Vedere lo fece abbassare con gli esplosivi e da quel momento gli abitanti di Consonno chiamarono la collina che non c'è più Monte Mario.
The hillside simply couldn't handle the amount of damage it had been dealt.
In particolare poi negli anni 70 ci fu una frana che bloccò l'accesso e Consonno venne completamente abbandonata tutto d'un tratto, mai terminata.
In 1976, the City of Toys Hotel closed for good, and the Count's dreams were over. But after the Count's death, another use was found for Consonno.
After the abandonment of the site as an amusement park, this place became an old people's home for several years.
It's got to be the most bizarre old people's home I've ever heard of.
And then it was abandoned again. That's when young people started to come here to organize great rave parties, and here they started to cover the place with graffitis.
In its own special way, the City of Toys continues to draw thrill seekers to this day.
Consonno è un posto molto particolare, è un posto che visto alla sera mette un po' paura.
Sì, questo posto sarebbe bello vederlo di notte, sarebbe più creepy, sì.
Consonno might be creepy, but it's perfect for playing one of Italy's less known national sports.
A national hide-and-seek competition? This is not the playground that the Count had in mind.
Today, the City of Toys is abandoned, and the Count's grand plan to build an Italian Las Vegas lies in tatters.
There's a lesson to be learnt here. If you're more interested in making a quick buck than building in harmony with the landscape, you're asking for trouble.
As every engineer knows, when it comes to building something new, if you ignore what lies beneath, you're just asking for trouble. Like this story in Ireland, and an eerily quiet housing estate.
It's just completely deserted.
This engineering calamity caused more than just house prices to sink.
It's every homeowner's worst nightmare.
Donegal in northwest Ireland, famous for its low mountains and lush green scenery.
They call Ireland the Emerald Isle for a reason. It's this epic expanse of green landscape.
But this epic wet landscape isn't always ideal for heavy engineering projects. This is the Ryerk-on-Shaskin housing estate. Although it was built just 10 years ago, it's now a ghost town.
It looks like a scene from a post-apocalyptic movie, as if the houses have been abandoned overnight.
It's been nicknamed the Titanic Estate, not only because everyone's abandoned ship, but because it's sinking.
At first, it looks like the houses have popped out of the ground, but then when you look, you see that the ground has sunk.
Engineer Francis Harvey is in charge of assessing what went wrong.
What we're looking at here is where the ground has settled well beyond what the houses have settled. This is the entrance ramp that was constructed in compliance with the building regulations for wheelchair access and disability access, and we can see that it's fallen off completely. This is the regional tower macadam that was laid after the houses were built, and this level was the same as this, which is the bottom of the paint. The down pipe had a gully, which was immediately beside it, but it has now sank down this far. This is the soil pipe, which takes the fittings within the house, the toilets and wash and basins, etc. This pipe would have gone down as far as here originally and connected to an upstanding pipe for the sewage, but the householder would have found it necessary to keep putting in these intervening pieces to keep in touch with the ground piece, which was sinking.
The sinking around these houses is all down to the very ancient, wet and spongy type of soil on which it stands. Local surveyor Hugh Boyle knows the lay of this land.
The main type of soil that we have here is peat, poorly drained and saturated peat. It makes it a very unstable foundation for anything that's placed on top of that because there is movement. It pushes the ground outwards.
Ireland is well known for its peat bogs. In fact, more than 10% of the country is covered in peat.
Peat is a type of soil created as vegetation decomposes in a water-saturated environment. As peat accumulates, it retains water, forming bogs and wetlands that gradually expand with time. Peat is widely used as fuel and fertilizer, but it's definitely not ideal for building on.
The sinking estate is just about 600-700 meters south of here, and as you can see, the peat here is very, very wet. If it's not removed, it does present many problems. Peat like this can have up to 70% moisture content. It's a soft material.
When peat is wet, it continues to decompose, releasing gases and reducing its mass. It's far from ideal for foundations.
The engineers who built the houses knew all about the peat underfoot, so they designed their foundations accordingly.
The houses are standing proud because the engineers put foundations going down into the hard rock, knowing that peat was an issue.
The foundations are concrete and steel piles that pass through the surface layer of peat, supporting the houses on the solid rock below.
Piles were designed, specified, and were installed correctly. The ground beam was correctly fitted on top of it, a reinforced concrete, and then the houses are built on top of that.
So, the houses themselves are solid.
As for the roads and the services area and the driveways, these were built on top of the existing ground, but it was specified that a geotextile material would be used.
Geotextiles are permeable fabrics designed to separate, reinforce, and protect ground while allowing water to drain. Layered with stone-filled ballast, geotextiles can make peat stable enough to build on.
This geotextile material was to be covered with approximately 1 metre of stone fill, and obviously that was not done, and the geotextile membrane has failed completely, and the ground is sinking and is continuing to sink. The amount of subsidence on the ground as compared to what the houses are is in place up to 1/2 metre.
As extreme as it looks, this Titanic engineering calamity might not be an isolated case. Another nearby community looks to be experiencing a similar issue, as local resident Liam White explains.
This estate was built about 12 years ago by a private developer, and they've been having trouble with sinkage ever since. The tower is moving out from the house. As time goes on, that'll go further and further away from the house. As you can see, the playground is a bit lopsided. The curbs are another example of the subsidence. It's a tough place to live when you have these problems outside, just outside your front door, basically.
Having the world sink around you is far from ideal. The question for Donegal's engineers is how they can combat these local peat-based catastrophes.
If it's shallow, you can scrape it away and fill in that area with something else. But if it's deep, you just have to put foundation piles going straight down to the rock below.
By securing piles into the rock beneath the peat, solid platforms can be constructed below the ground surface. As well as for houses, these provide reliable foundations for roads and services. However, for an existing estate, it's not an easy fix.
To create platforms under the ground and around these houses will be very tricky, and not to mention hugely expensive.
The real solution here would be for engineers to get it right the first time round.
The houses weren't going to sink if only as much attention had been paid to the surrounding area.
The repair bill for this estate is estimated in the millions of euros, and more than 10 years later, these houses remain abandoned. Construction calamities come in all shapes and sizes, messy or maverick, big or small. So long as we keep building, there will always be more engineering mistakes to fix.